So we're going to find the slope of the line tangent to this polar curve at theta equals pi. So this is a dy dx question. That's important to understand because uh, our graph is in polar coordinates r equals 2 cosine theta. So we need to get this. If we're looking for dy dx, we need to convert this to the rectangular system. So we know that, first of all, dy dx, according to our parametric derivatives, it's going to be dy d theta divided by dx d theta. Let me change my color. That's too thick of a pen. So let's talk about y first. Y is always r sine of theta. So y is 2 cosine theta minus 1. That's r times sine theta. So just times sine theta. So we're going to use that for the dy d theta, and it's perfect because we can easily differentiate y with respect to theta now. So the dx d theta, first we have to figure out what x is. X is always r cosine theta. So I'm going to write r, which is 2 cosine theta minus 1, and then times cosine theta. So now I'm going to take the derivative of these and just put them on this fraction. So I have dy d theta over dx d theta. Now, the top one I would use a product rule for. The bottom one, you don't need a product rule because you can write this as 2 cosine squared theta minus cosine theta, and then just use the chain rule on the cosine. The reason why I wouldn't do up top is because you would be multiplying out to just make another product rule. So it's not really worth it. And you don't really have to multiply this bottom one out either, but I'm going to do it just for a change. So the dy d theta, let me change this to blue so it's the same. It's the first 2 cosine theta minus 1 times the derivative of the second, which is cosine theta, plus the second sine theta times the derivative of the first. So the derivative of 2 cosine theta minus 1 is just 2 times a negative sine of theta. So that's my derivative of dy d theta. And now I'm going to take the derivative of this x. Down below, so there's no product rule necessarily. You can use a chain rule here. So I'm thinking of this as cosine theta squared. So I'm going to use the chain rule on this. So bring that 2 down. So it's 4 cosine theta to the first. Then times the derivative of the inside. And cosine's the inside. So times the derivative of cosine, which is negative sine. So I'm done with the chain rule on that first term. And the second term is the derivative of negative cosine of theta, which is negative sine, so plus sine theta. So this is my derivative. Let's move all this stuff out of the way. So I'm not going to simplify because I know I'm trying to look for the derivative at theta equals pi. So I find it easier when I have a value I'm taking the derivative of is just plug it in for the pi here. It's easier than simplifying this trigonometric expression. So let's do it. So at pi, so this at theta equals pi would be, so I'm going to start here. cosine of pi is -1. So we have 2 times a -1 minus 1, which is -3, times cosine of pi is a -1. So I'm going to have 3 up top, plus sine of pi is 0. So that eliminates the entire second term. That's nice. So I have 3 over. Now I'm going to plug in pi to the bottom. Now this, I probably should have checked this first, because do you see if you plug pi into thetas on the bottom, both of these terms have a sign. So both will be, the first term will be something times 0 because sine of pi is 0, and then plus 0. So I know that the slope of the tangent line here is undefined. Now, it could be a corner or where the graph is not smooth, or it could be a vertical tangent line. It would most likely be a corner if the top was 0 as well, but it's not. So it looks like it's probably, by the way, the answer to the question is the dy dx is undefined, and it's probably because there's a vertical tangent line. Divided by 0. So now I'm going to use my calculator to check that. So I'm very much expecting this to have a vertical tangent line. It's always nice to check. So here's my graphing calculator. I was dealing with another graph here. It was in rectangular mode. So I want to change it to polar mode. So I'll hit the mode and change it over to polar. And then type the equation into polar mode. And you can see I already did that. And then see what the graph looks like. So the graph, let me zoom. Standard. Now that looks pretty good. Now I'm going to zoom in actually, because I think it will look really good if I zoom in just once. So as a matter of fact, let me extend the window just a little bit to the right so we can see the whole graph. So what we're saying is that this graph is undefined at theta equals pi. So I have to figure out where pi is. It's probably right here or right here, because that's where it looks like it has a vertical tangent line. To verify where pi is, you can use your calculator. You can just go second calculate and then just find the value at pi, because it will locate pi for you. So second pi. And look, it was right there on the right edge, which would have a vertical tangent line, and thus the derivative is undefined, so that's good. Now, I don't know if you noticed, you've probably noticed this before, but let's go back to the calculator, because I noticed something while I was looking at the calculator. When I hit that calculate screen, it will calculate dy dx. So let's try it. So I hit 2, and I'll now again put pi in. Quit. Divide by 0. So yeah, that's undefined. We're dividing by 0 just like we knew. I didn't want to say quit, but that's what the first word I saw. So that's it. Now one more thing, because the more information, the better. You notice that there was a drdt there, or drd theta. That's not what we were looking for. But let's just find out what drd theta was at pi. Now that means the rate at which r is changing. R is the distance to the origin as theta is changing. So we know that theta, so theta is pi. It tells us drd theta is 0, which means the distance at that moment that it's that it's changing from the origin is 0. that's strange, but that sort of makes sense because if you follow this graph around, remember d theta is the rate at which r is changing, and I don't know what I'm doing here. Hold on, let me try to. I know this video is long enough as it is, but I lost my cursor. All right. So I just want to look at that because that's something really important to look at. So we said at that point, d theta is 0. And if you think of r changing, r is the distance from the origin. So that's right next to that point. That's right next to that point. Well, it looks like if we're moving these lines, they're going to max out here. So r is going from increasing to decreasing or vice versa, but it does max out here. So that would mean if the rate is changed from increasing to decreasing or vice versa, that at that very point, it would have to go through 0. So at that point, it's not getting any further or closer to the origin. So hope that made sense. But that's that. Practice these problems and actually do pay attention to the grass and look at the grass. It will help you understand everything just a little bit better. So now I'm just looking to see how to turn this thing off. There we go. And I'll see you next time.